This week we're going to subclass our Neurode class into a feed-forward Neurode class. The feed-forward Neurode is going to handle the information flow in the forward direction in our network. So first, let's review how our multi-layer perceptron works. We'll draw a simple network here, perhaps 2 input layer nodes, 2 hidden layer nodes, and a single output node. Remember that our network is fully connected, so from each input node, there's a connection to both of the hidden layer nodes. And from each hidden layer node, there's a connection to the output node. We supply data to the network at the input nodes. We call that an example. Without doing any processing, the input nodes pass that information onto the hidden layer nodes. Each hidden layer node does a little bit of calculation and passes the results onto the output layer node. The output layer node does its own calculation and comes up with a value that is the output of the network. Each of these nodes basically has the same functionality, so we'll build just one class and then reuse that class to create all the nodes we need for a network. Let's look more closely at what a single node needs to do. A single Neurode might have several input connections. For simplicity, we're going to assume that our Neurodes have just 2 input connections. We'll talk about input layer nodes later, but a hidden layer or an output layer node has its connections coming from other nodes in the network. Remember that we used an ordered dictionary to keep track of the incoming nodes, and that the node object itself is the key to each dictionary item. The value of the dictionary entry is a weight that we created randomly. I put some possibilities here. When node 1 calculates its value and has some information ready for our node, it will call the receive input function on our node. Let's see what this function call would look like from the point of view of node 1. Node 1 wants to call receive input on our node. So inside node 1, we'd call our node.receive input. And the first argument we're going to include is self. We don't usually use self as an explicit argument, but from node 1, we actually want to pass the node 1 object into our node because we're using it as the key for the dictionary. Since our node is a hidden node, we're not actually going to receive any information from node 1. Node 1 is just letting us know that the information is available. So actually self will be the only argument that we list. What does this look like inside our node? Well, we have a method receive input that takes 3 parameters, self, from node, and input value. We're not going to use the input value parameter. It has a default value of 0. But it's really important to understand that the self argument that was included in our call to receive input from node 1 is actually getting passed to the from node parameter in our node. So what does receive input do? Really, it doesn't do much. Since we have a hidden layer node, all we're going to do is directly call register input. And register input takes on the responsibility of keeping track of which incoming nodes have information available. Remember that we used an ordered dictionary to keep track of all the incoming connections, and that with an ordered dictionary, we can find out the index of each key. So the index of node 1 should be 0. And just like we did in factor breakout, we're going to use that index number 0 to determine which bit in our binary encoding we should mark. So if we've only received information from node 1 has an index of 0, we should only have the bit in the ones place marked. Our binary encoding reporting inputs should look like this. The other thing register input is going to do is check whether reporting inputs is full. If it is full, we're going to clear reporting inputs and return true. If it's not full, we're simply going to return false. In this case, reporting inputs has a value of 0, 1, so it's not full. We would return false. Later, when node 2 comes along and tells us that it had some information, its index is 1, so the bit value we're interested in is the 2's place. We'll update reporting inputs, so now it has a value of B11, 1. Every bit is marked, So we're going to clear reporting inputs and return true from register input. This indicates to our node that all of its incoming connections have data available. At that point, we're ready to fire. Fire is a two-step process. The first step is that our node needs to figure out what its value is. Our node's value depends on the value of the nodes before it. So we need to ask node 1 and node 2 for their values. For simplicity, let's suppose that node 1 has a value of 1 and node 2 has a value of 0.5. We need to calculate the weighted sum of all those values. We do that by multiplying the value of each node times the weight of its incoming connection. So 1 times 0.62 equals 0.62, and 0.5 times 0.54 equals 0.27. We add up those values. In this case, the sum is 0.99. The sum could be greater than 1, but we're going to pass this value to our activate sigmoid function to normalize it between 0 and 1. The value of our node is the output of activate sigmoid when we pass it the value of 0.99. We're then going to let the nodes in the next layer of our network know that our node has a value available. And we do that by calling receive input on each of those nodes. Remember, we'll be passing the self object as our only argument. And that's pretty much it. The only other thing we need to do is consider how an input node would behave differently from a hidden layer node or an output node. We're going to use the same class for all of our different types of nodes. We'll simply put an if block in our receive input function that'll cause the different behavior for an input layer node. Remember that our receive input method has 3 parameters: the default self parameter, from node, which is going to be none for an input node, and input, which has a default value of 0, and for most nodes we're not going to use, but our input node will actually receive information on this parameter. All the input node is going to do is store input as its own value and call receive input on all of its output nodes. So whatever value was passed to our input node gets stored as its value, and all the input node does is let the next nodes know that it has a value available. It doesn't need to do any calculations. It doesn't need to call activate sigmoid or anything like that. And that's it. I hope you have fun coding up this class. Be sure to ask and answer questions in the discussion forum, and of course, attend office hours.